The master has entered the ring. Hey guys, it's Michael here, hopefully your next favorite LeetCode tutorial person, teacher. So today I was thinking about how I could
Oh,
you guys up long and hard. Now I know there's some people that actually like to go slow a little bit, so I'm gonna go slow a little bit. So this next question here is not exactly like a baby question, however, it's not an adult question either. So think about it more like, if I were to give it a range, think of it more like a toddler question. So let's get right into it. Alright guys, so the question that we're trying to answer here is relatively simple. Given an integer value, how do we output the corresponding Roman numeral for that number? We have to create a function that does that. So let us go ahead and see how we can figure this out. So here we have a table which, I just literally copied it from LeetCode, but whatever, which has the mappings between the Roman numerals, the single digit Roman numerals, and the integer values. So here we have I is equal to 1, v is equal to 5, x is equal to 10, so on and so forth until we get m, which is the largest single digit value, which is equal to 1000. So the Roman numeral system has some rules. For example, the I can come before the v to get 4, and it could also come before the before the x to get 9. The x can come before the L to get 40, and it could also come before the C to get 90. And C could come before the D to get 400, and it could also come before the M to get 900. Now, another rule that that the Roman numeral system has is that you cannot use 4 of the same symbols together to represent a number. So, for example, you cannot have I, you cannot have CCCC, you cannot have that equal to 400, and you cannot have XXXX. But you can have I, you can have CCC, and you can have XXX, which I'm pretty sure a lot of guys will be happy because every one of us likes to watch XXX every once in a while. Come on, don't lie, you know who you are. Okay, so now that we know the rules, how do we actually solve this problem? Now this is actually where I have to introduce a concept called greedy algorithms. A greedy algorithm is an algorithm that, given a list of choices, it will always choose the best choice at the time, and it'll apply that choice to the solution. So let's see how we can implement that here. The table, in this case, the choices that we have are represented by the Roman numerals. So here we have I, V, X, L, C, D, M, IV, IX, XL, XC, CD, and CM. So now we know what a greedy algorithm is. How are we going to implement one here? Well, the trick is that when we have a number, what we can do is we can subtract that number by the largest possible number that we can use to represent it with the Roman numerals, and with a single digit Roman numeral, and we're gonna add that Roman numeral to the string, and then after that we're gonna keep doing that until the number reaches 0. So let me give you an example here real quick. Let's say, for example, we have the number 49 here, right? That's the number we have to represent. So what is the largest Roman numeral that we have from this list of choices that I talked about? What is the largest Roman numeral that we can use to represent this? It turns out that that Roman numeral is XL, because XL is equal to 40. So our answer here, is going to be equal to XL, and then we're going to subtract 49 minus 40 so that we can represent the rest of the number. And so the rest of the number that we have to represent is 9. And what is 9 in Roman numerals? 9 is 9 is IX. So go over here, you write IX in the answer, and then we subtract 9 minus IX, which is equal to 9, and that'll equal to 0. and then once is equals to 0, our algorithm is done. And so the answer here, in this case, is XLIX, which, as you can see over here, is the correct answer. So let's try another example. Let's try the number 3,999. This number is the largest number that can be represented by Roman numerals. So what's the largest Roman numeral digit that we can subtract from this number? That would be m, because m is equal to 1,000. So we subtract, again, by 1,000. Sorry, 1,000. We get 2,999. And to our answer, we add m. And now to 2,999, we repeat the same process. What's the largest single-digit Roman numeral that we can take away from this number, from 2,999? That's m again. So we put another m. We subtract 2,999. Again, I'm not an artist, I'm sorry. Minus 1,000. And that's equal to 1,999. Again, we ask ourselves, what's the largest single-digit Roman numeral that we can subtract, or that we can take away from 1,999? That's m again. So we add another m. And then this would equal to 1,999 minus 1,000. 1,000. Some derpy ass drawings here. Some derpy ass numbers. We end up getting 999. What's the largest number, the largest Roman numeral that we can take away from 999? Well, it's no longer m because m is equal to 1,000. So that would be cm in this case, 900. So we add cm to our answer. And then try 999. Let's bring this up a little bit. Minus 900. And this would give us just 99. And so what's the largest number, the largest Roman numeral that we can take away from 99? Well, that is, that is xc. xc. So we write xc over here, xc. We subtract 99 minus xc, which is 90, and we end up getting 9. And as we said before, 9 is equal to ix. So we write ix, and then 9 minus ix, which is 9, is equal to 0, and here our algorithm stops. And the answer here is, in this case, MMMCMXCIX, which if we check over here, we get 3,099 in Roman numerals. We get MMMCMXCIX, just like our algorithm. So now how are we going to implement this into code? Well, it's actually quite easy. All we got to do is just copy and like, all we have to do is just declare a variable for every single Roman numeral that we can represent. And then we just write a while loop, and then we do what we do before, where we're subtracting numbers. We just, for every while loop, you write an if statement for every single symbol that we have, and we say if this symbol, if the number right now is less than this symbol, then add the symbol to the answer, and subtract the number, take away the symbol from the number. So let's see, integer I is equal to 1, integer v is equal to 5.
A few moments later.
So here we have all the possible combinations. Now we declare a string here, which will be our answer. It's going to be initially empty. Now usually for these sorts of problems you could probably use a string builder instead of just a simple string, but this problem is simple enough to just use a string, so we're going to use that instead. And here we have a while loop, and we're going to say while num is greater than 0, and here we say if, we're going to check it against the largest value first. So in this case it would be m. So if num, in this case we would say if num is greater than m, or actually it's greater than equal to m, then we concatenate m to the answer. So so answer is equal to answer dot concat, and we're going to say m, the letter m. And then we're going to subtract numbers, num by itself, and m. So num is equal to num minus m. And then we're going to do this for every single one of the Roman numerals, but starting from the biggest one, the biggest Roman numeral, to the smallest one.
One eternity later.
Okay, damn, that was a lot of work. Here it is. Here are all the checks, which check to see if the number is less than or greater than equal to each one of the symbols. With this, it does the check. And if, for example, num is greater than or equal to m, it concatenates the answer and it subtracts m from num. In the end, we should have the answer. So I'm just going to say return answer. And let's submit the code. Let's see if we have any errors here. And we don't have any errors. The runtime of this is 4 milliseconds, but it uses quite a decent amount of memory. So how can we improve upon this algorithm? Well, there is certainly a way, actually. Especially because the way that this algorithm, the way that it's written right now, it has a bunch of if-else statements. But there's a way to simplify this, and that's what I'm going to show you right now. Alright guys, so now I'm going to show you a much cleaner solution to this problem. So as you can see over here, I've changed the mapping a little bit from the table that maps the numbers to the Roman numerals. I instead just separated the numbers into one array and then the corresponding numerals into another array. And both of the array lengths were 13, so I just made a separate variable for that. And so what we're going to do actually is we're going to write a for loop that goes from the very end of this array here, and it'll try to subtract the value that is at the very end of the array up until subtracting that value from nums would yield a number that is less than 0. So that means that if the number is less than 0, that it cannot be used to represent the number anymore. So at that point, we will just move on to the next number, and then we're going to keep doing the same thing over and over and over again up until we get to the very end of the array. So for that, we're going to need a for loop, which is going to have for integer I is equal to array len minus 1. I is greater than or equal to 0, and I minus minus, since we're going from the end of the array. And then over here we're going to have a while loop. We're going to say while nums minus choices integers and I is greater than or equal to 0. we are going to subtract choices integers I from nums. Choices integers, nums minus equal choices integers, add I. And then we're going to concatenate the corresponding Roman numeral to the answer. So I actually forgot to declare the answer, so string ans is equal to an empty array, and then an empty string. And usually for these sort of things you would use a string builder, not just a string, but this problem is simple enough for us to just use a string, so I'm going to do that instead. And so we're going to say ans is equal to ans.concatenate, concat, and we're going to say choices Romans add I. And this should be it, so we should just return the answer. Let's take away, it's not nums, it's num. And this should be it, so let's just run the code. Submit it.
Mission failed. We'll get 'em next time.
Cannot find array len. Oh yeah, because it's arrays, not arrays. It's arrays. Submit. And as you can see, our runtime is 4 milliseconds, similar to the other one, and this one uses a little bit, I think the same amount of memory, more or less, maybe a little bit less. This is quite a decent amount of memory. But overall, this is a much cleaner looking solution. So if you're in an interview and they ask you this question, make sure you give them this solution, because this solution is the cleaner one. So I kind of made a mistake before. Typically there's some corner cases that you need to take into account. These LeetCode problems, in this case, the Roman numerals can't represent any number that's less than or equal to 0. And you also can't represent a number that's larger than 3,999. So in this case, we're going to throw an illegal argument exception if the user attempts to do that. So we're going to say if nums is less than or equal to 0, or num is greater than 3,999, we're going to say throw new illegal argument exception. I'm going to run the code. Oh, what am I doing? There you go. Submit. Submit. And there you go. Well, guys, that was it for this video. Please like, subscribe, and comment down below if you have any suggestions as to what other LeetCode problems you want me to do. For now, I'm just going to sit back, relax, and do some more freaking LeetCode. This is your favorite tutorial person, guy, thing that's supposed to help you get a job but not really, guy, Michael, signing out. See ya.